All right, well, that was quite the intro, Nicole. Thank you. As you may know, my name is Brian, and I work here at 8th Light as a crafter. And so today, I'll be going over functional programming with Elixir. Cool. So before I start my talk, I want to just go over this quote that I found on the internet by Zig Ziglar, which is, "You don't have to be great to start, but you have to start to be great." And this resonates with me because I'm very nervous right now. I am not good at public speaking, but I want to get better, right? So what better way to give a talk, right? Just face your fears head on. So with that said, I did write this about me slide, but you already know. Yeah, I guess I can just talk about the picture. That's me standing on a rock near one of the routes that I've been on before, just once, and only once, because since I ride a fixed gear, there's like this crazy descent on that route, and I was very uncomfortable with that because I don't have brakes and I just have to rely on my legs for brakes. Very dangerous. Please don't follow me. Yeah, ride with brakes. That's all I got to say. So into the nitty-gritty. What is functional programming? So the definition of functional programming is it's a declarative programming paradigm where programs are constructed by applying and composing functions. This is obviously different than OOP because instead of functions, we use classes and objects in OOP, right? So that's pretty much the main distinctions between the two. So going over OOP, as I mentioned, software design is organized around objects. It follows an imperative programming model. It allows for mutability, so you can change variable data, stuff like that. And also loops are used for iterating data, right? We have the for loops where you initialize the index to 0, and then if it's less than the list length or whatever, we've all seen for loops before. Or at least I hope. And if not, then no pressure. All right, so functional programming is sort of like the opposite, right? So software design is organized around functions, and it follows a declarative programming model. Does not allow mutability, so you can't change the variable state. And then instead of for loops, we use recursion. So this was one of the things that was I was struggling with when I was first learning functional programming, is because I hardly used recursion before. And so during my apprenticeship, I was tasked to create a tic-tac-toe application in Elixir. And I struggled because I was well, I know Ruby, I know JavaScript, how hard can it be, right? It was, at least for me, a huge struggle to wrap my head around using recursion and not being able to modify variables, stuff like that. So yeah, it was a fun journey. I ultimately got that program done, and now I love Elixir. It's I'm using it right now. It's one of my favorite languages, and it kind of taught me to write more functionally. At least if I ever pick up Ruby or JavaScript again, then I want to apply the more functional programming sort of mindset when I write my code in the future. All right, so second half of this talk is Elixir, which I will be focusing on. I'm just going to give a brief definition of it, and then towards the end, I'll give a demo. And so we can see some of the features that I think are pretty cool. There's obviously a lot about Elixir, so I'm not going to touch on everything, but I'll just show you some cool things about Elixir that I found really cool when I was first learning it. All right, so as you may know, it's a functional, concurrent, general purpose programming language. And it was introduced in 2012 by Jose Valim. He's actually really cool. I highly recommend watching any of his talks on YouTube or anything like that, or just following him on GitHub or Twitter or whatever. So Elixir, in mind when it was being created, was they wanted it to be highly concurrent and low latency. so that it can be scalable, used in large applications, and handle large data volumes. And today, it's successfully used in web development. So Phoenix is sort of the web framework for it. There's also Live View. I'm actually doing Phoenix Live View on my current client. And it's pretty cool because it's server-side rendered, which that was also kind of like the introduction of server-side rendering for me, was working in Phoenix. And it's used in embedded software, data ingestion, which my client currently uses Elixir for, and multimedia processing. So some features about Elixir is that it's built on top of Erlang, so that gives Elixir access to all of like Erlang's concurrency and like low latency tools and stuff like that. It's dynamically typed with Ruby-like syntax, so that's what like I really like about it, because like before I did Elixir, I knew Ruby, so it wasn't that hard to sort of like get into the syntax. More so just like the paradigm was a lot different, but syntax is like very similar. There's something called pattern matching, which I'll show you in the demo, and that's great because then it makes your code look more declarative and be more declarative. And then immutability, like I said, so you can't like change a variable once you sort of like initialize it. So what I mean by that is like, if you initialize variable named like A, don't use A in your code, like, you know, please be more explicit. But for example, like, you know, you set A to a list, and then like Ruby or JavaScript, for example, you can do like a dot push a value. And if you were to like inspect A, you would see that value appended. You can't do that in Elixir. And I'd say most of functional programming languages, if not all, I'm not sure, I only know Elixir. So also everything in Elixir is an expression, which means that everything will return something. There's like no statements where, you know, statements can like not return something. And then piping, which I'll also get into, but it's like a cool syntax where you can feed the return value of something into another function. And so it just looks pretty cool when you look at it in person. All right, so that was it. That was me talking. I will go over my demo right now. So I want to go over piping first. So I already made this project called Playground. I'm going to open it, open up some of these like boilerplate files here. And then let me open up the test suite. So I have a test runner running, and this is the only test I have and the only code essentially. So we're just testing that hello returns world. I'm going to obviously replace that. So this example, or for this demonstration, I want to make this kind of interactive. So so pretty much the problem is, given a string of numbers separated by spaces, return a list of only the even numbers and have that list be sorted. So I'm just going to do returns a list of even numbers given a string of space separated numbers. Stuff here. It's going to fail, obviously. All right. So to the audience, if you could please give me like any number between 1 and 100, have it be odd and even. I'll take the first 8 numbers for this example. So 33 to, let's see, 33 to 27, 15, 8, 99, 78. That's 7. One more, 7. I'll just do, all right, 45. That's 9 numbers, I believe. Okay, so we have this string. and we're kind of expecting this to return, or we are expecting this to return 2, 8, and 78. That's it. Okay. So given this string, we want to return this list, right? So we could write it like this, right? We have our string, and first thing we want to do, I suppose, is to create a list of this, right? So there's a method called string split, which will take the string and return an array of each element where, like, you know, separated by spaces. So let's do string list. These are bad variable names. I'm just doing it for demonstration purposes. Yeah, I always try to make your variable names be more explicit, but for me, I'm just going to do it like this right now. So split this, and then we will pass in the string. So this is going to return just like a list of, you know, strings for now, right? And so we want to obviously convert those strings to numbers. So we will iterate through that list and convert them to numbers, or iterate through each element and convert it into a number. So let's do num list. Let's map over the string list. For each element, this is the syntax. It's kind of similar to like the arrow functions and like JavaScript when you do like a map, sort of the same thing. So here we want to return, I believe it's string to integer, and then x. This will give us, actually, I am not doing it in the right spot. Please ignore me. I'll do it here. Okay, I'll just leave this thing for now, but in any case, we're trying to do TDD, right? So let's, you know, write the test first. So assert playground dot, we'll call it just convert, pass in the string is equal to 2, 8. And I'll just comment this out for now. All right, there we go. It's expecting convert, but it's undefined or private, and it's obvious because we did not define it. So let's do this. And now we can go back. Sorry for that. All right, so where are we? We're at the part where we have a list of numbers now, right? We don't have a list of strings anymore. So now we want to filter out any odd numbers, right? So we can do another thing where we filter out, we'll pass in the num list, and then for each element, we will filter out anything that is like remainder 2 is 0, or remainder 2 is 0. So x and 2 is equal to 0. So this will give us a list of even numbers, unsorted. Sorry, I forgot to put that here. Returns a sorted list. Okay, there we go. That's why I forgot to mention that, but you know, the result here is that it's sorted. I guess it's already like sorted here, but whatever. I guess, okay, let me just put the 78. Oops. No. I'm not that good at Vim, so please excuse me. All right, we'll swap 70 and 8 so that, you know, it's more, you know, we can see that gets sorted, right? All right, so last but not least, we have our even list. Now we just need to sort it, right? So sorted list is equal to enum.sort method, and we just pass in the even list and return the even list, or the sorted list, sorry. Oh, whoops, yes, I want to save it. Missing terminator end somewhere. Oh, right here. Cool. So we see that we converted this string of numbers into a sorted list of even numbers. But if we look here, it's kind of like, okay, we're gonna, take this return value, store it in a variable, and then pass that variable into another function and then store that. Like it's kind of hard to read. We can make this a lot better with piping. So with piping, it's essentially passing in a value as the first argument in a function. So here we see that we're passing string into split here, or str into split. So that's kind of like our entry point, right? So I'm just going to move this stuff down here for now. So we'll start with that. So we have our string, our str, and we're going to pipe it into string.split. Notice that we're not passing anything into split anymore because it's the syntax doing it. It's essentially just taking this value str and shoving it inside the function signature. All right, so now we want to follow this step, right? So we're passing in string list into enum map as the first argument. So let's do that. And then here we don't need to define string list. We just need to define that function to return or to convert them into integers. And we can do that by doing whatever we did here before. Integer. And then the next thing we do is filter out the even numbers. So enum filter. So instead of writing this fnx blah blah blah, there's a special syntax in Elixir where you just do ampersand, and then x will be referred to as &1. But here we want to do the remainder of that, right? So remainder of &1 and 2 equal to 0. All right, just make sure I close my parentheses. And then lastly, we want to sort this list, right? So num sort. So let me just comment this out for now. Oh, by the way, &1 just refers to the first argument here. If you have multiple ones, then x will refer to &1, and then y will refer to &2. But in this case, we only have one, so we just use &1. And cool, our test still passed, but I mean, it's a lot better to read it this, as opposed to following this. I mean, this might be easy for some people, but I guess personally, I would rather look at it like this because it's much cleaner and more declarative. So that's piping. I really like piping just because of that. This looks very clean in my opinion. So, all right, so piping 101 done. The next thing I want to do is I want to demonstrate the Roman numerals kata, and then by doing so, I can go over some of Elixir or more fundamentals of Elixir. So I'm just gonna remove this for now, and then remove this test so we can start on a fresh slate. So if you aren't aware of the Roman numerals kata, it's that any Arabic number we pass into a function. So let's say we have this Roman, I guess it's called playground. That's the name of the module, playground dot convert. If we pass it an Arabic number, we should receive the Roman numeral. And that's kind of it, right? Just pass in any Arabic number and then we'll get the Roman numeral. Pretty straightforward. So let's write our first test. Returns I for 1, right? And let's just assert that playground.convert 1 is equal to I. All right, cool. We have to define convert again. So let's do that. And then here, so like the basic rule of TDD is you write a test and then have that test fail and then write the least amount of code to get that test to pass. So in this case, I'm just going to return this I, right? Cool, we have our passing test. Let's do another test. So let's do II for 2. Okay. II, there we go. All right, we don't have logic to handle this, so let's add it. If num is equal to 2, return 2, else. Bam, easy, right? Let's do some more. Let's do 3. All right, we can just keep doing this where we just do 3. And then if you're familiar with other languages, we would have like something like else if here. Else if. But wait, we can't do else if in Elixir, right? We get this error, missing terminator end for do starting line 1. So in Elixir, you just can't do else if inline like this. But there is like sort of a way to get around this by just creating a new block inside the else. I think this will auto format, please. Cool, right? That's kind of the way to get around it. So just one thing to note, you can't do else if inline, but you can do this little sort of hack here. All right, so we're at this point now. If we keep adding stuff, it would just be, if num is equal to 4, blah, blah, blah. We don't want to do that. So right now, I'm going to demonstrate what they call pattern matching. And so if we look at our tests, we're calling playground convert with 1, 2, and 3. We can define these sort of methods that match those arguments that we're passing in, right? So let me just remove this. Do converts 1. And then this is syntax to, if you're only returning like a single line within your function, you would just do comma do, except with the colon at the end. Here, this will be 1, 2, 3. So what this is doing is that when playground convert, I guess for the example for 3, when this function gets called with 3, it looks at each function, right? Oh, is this 1 matching a 3? No. Is 2 matching a 3? No. Is 3 matching 3? Yes. So we call this function, and that's how we get our return value of I. And that's the same for 1 and 2 as well. All right, so what if we write a test for 4? So here we're going to get a different error this time. And what this means is that we're passing 4 into this convert function, but there is no function clause matching it, right? We only have 1, 2, and 3. So if we try to pass a 4, like it doesn't know what to do and it can't call any of these. So it just sort of blows up, right? So easiest thing to do to solve that is just create one for 4, right? Oh, whoops, I copied the one above it. This should be ID. All right, so that sort of explains the pattern matching just a little bit, at least in terms of functions, but we can go a little bit more deeper with pattern matching, and I'll also introduce like something called guards, but just explaining what I do before I do it. So let's refactor this, right? Let's make it more sort of flexible, right? Because otherwise we can just keep, pattern matching whatever Arabic numbers I want to test and then just return the associated Roman numeral. So I guess I'll just remove this for now. Let's just call this sort of, flexible convert function. And then I'm going to define a function called doConvert. And here we want to pass in the number. And then I guess before I do this, I'm going to initialize something called a module attribute, which is like a constant variable in most languages. Like, so if you're familiar with like JavaScript, it's just like const and then like the variable name with all capitals. So this is just a like value that won't ever change and that it could be reused anywhere in the module. So let's call this like Arabic or something. Add name, but we want this to be a list. Here I'm going to define tuples of like the possible Roman combinations you can have, right? So at least the special ones, right? Because 4, will correspond to IV, and then 1 is just I. We're not defining 2 and 3 because, it's just going to fall back to I, if that makes sense. So, okay, now that we have our Romans, let's define our function that we'll be calling recursively. And I haven't written it yet, but I will show you what I mean in a sec. So here we want to pass in the Romans and then an empty string. So the empty string is going to be what we append to sort of get our return value back, right? We're going to iterate through each element in the list. Check if the number is greater than or equal to the Arabic counterpart. And if it is, then we subtract the Arabic from the number and then append the Roman numeral to the string. So let's write that. In this case, I'm going to make this a private method or private function, and that's just appending a p at the end. So we want to pass in the number, or this takes in a number, and then we're going to call this the values, but that just corresponds to the Arabic Romans up here. And then the string, which is result. All right, so if we think we want to iterate through the list and then, subtract the Arabic from the number if it's greater than or equal to, and then if it's not, then we want to move on to the next element in the list and then do the same thing. But then there's going to be a point where like you've successfully iterated through everything, you don't have a number anymore because like you subtracted that last one from it, for example. And so now like you need to return that result, right? Because there's nothing left to iterate. And that's like what they call a base case in recursion. So we can write our base case here. So if we iterate through the list and then we don't have anything left, so that values is empty, that would be enum.empty values do result. So if there's nothing left in the list, we're going to return the string, right? Else, if the number is greater than, actually, before I do this, this is where I get into pattern matching more. So our values here is a list, right? And we want to grab the first element in the list, right? This is like, I guess when we first start the iteration, we want to look at the first element in the list. So there's a special like sort of syntax for that. And that is this here. And this is pattern matching on values because since value is a list, we pattern match this list, right? That's why we have the square brackets around it. And what this head returns is the first element in that list, and then tail will return a list of everything else minus the head. And we can kind of look at that more. So just head, tail. This test is not going to pass. Undefined function do convert. Oh, whoops. Convert. There we go. I mean, you're going to see this happen, what, 4 times, because every test is just doing it essentially. But we see that head is like that first tuple, right? It's not in a list, it's just that first element, but then tail is everything else in the list. That's why you see the square brackets around it. And I mean, there's only one element left, so that's why you only see this tuple, this single tuple. So with that, we have our head, and head is a tuple, right? So we have our Roman and our Arabic. We can also pattern match on that by pattern matching the tuple. So that's why we use the curly braces. We'll grab the Roman, and then we'll grab the Arabic. That'll be head. So we've essentially pulled this Roman into a variable, and then same with the Arabic into a variable. Now this is where we do our calculations. So if number is greater than or equal to Arabic, then we want to call this again recursively, right? Except we're going to subtract the Arabic from the number. And so since this, it's hard to see because okay, so anyways, since the number is greater than Arabic, we still want to use that same like place in the list, I suppose, that same list. So in this point, we're just going to pass in list, right? Or values, I suppose, that's the name of it. But we're passing in the same sort of like list because we still want to use this first element in the list, because there could be instances like, for example, 22, where we have to append 2 x's in the front. So that's sort of what we're doing here. And then for our result, we want to append that Roman value, right? So this is the syntax to append to a string. It's kind of this like weird 2 arrow bracket thing, what's going on. All right, that's our first sort of conditional. Else, if the number is smaller than the Arabic, then this is when we want to go to the next element in the list. So we're going to call our doConvert function recursively again. We're not subtracting anything from the number. And now, if we want to go to the next element in the list, we just pass in the tail, right? Because tail returns a list of all the other remaining elements. And do nothing with the results, right? Cool, our test passed. So like, you know, this seems okay, but we can do a lot better, right? And we can do this by doing more pattern matching. So if you notice, our base case is just checking to see if values is an empty list, right? Like if you want me to show you an example. We call enum.empty on an empty list. That's true, right? So we can extract sort of logic here into its own function again, right? And oh, it says my internet is unstable. Can everyone still hear me? Hopefully I didn't. Okay, cool. Thank you. All right, so We want to call this recursively again, except we want to match this empty list, right? And we can do that by just defining the function. And instead of values, I'm just gonna write in what we're expecting it to be, right? Or like what we want to match. So we want to match on an empty list and then result. And then that part of the conditional just returns the results. We'll do the result here. And then it's going to complain at me because I'm using this variable num, or I'm not using it, and it suggests to prefix it with an underscore. That's also sort of like the behavior, like the convention to do in Elixir. If you're not using any of the variables, just prefix it with the underscore. It's like, it turns green, so it's like, you don't really focus on it too much. All right, so we've effectively removed this first part of the our previous do convert function. So we run the test again. It should still pass, right? But we still have like this if else stuff going on here, and we can extract that into its own functions that we just pattern match on. So let's take a look at the first one here, this if statement. We're checking if number is greater than or equal to Arabic, and if it is, we call this sort of variation of do convert. So we can do that. We define do convert, and then this is where it's going to get like a little confusing, but I hope you can bear with me. So see, like here we're pattern matching on values here. We can pattern match within like this sort of like the function signature, or like wherever you define the function. I'm like blanking out on the name of this, but you can pattern match it inside the round or the parentheses, I'll just say. So we can do that. And effectively, we don't have to write it like this anymore, right? Or like, I guess, write it in a new line. We can just do it in line. And then our result, right? Do this. All right, so we still have like a little bit of work to do. So we can get rid of this part because we're defining it in line now. And now we're also pattern matching on head. We're getting the Roman and the Arabic. We can also pattern match it within the function. So we'll do that, Arabic. That removes this. And then we still have to consider, like, we only want to call this function when the number is greater than or equal to the Arabic. So since we've pattern matched all this stuff in here, we have access to the Roman, the Arabic, the tail, stuff like that. We can write a guard and use those values. So guard looks like this. It's essentially just like, okay, only call this function if this condition is true. So we do that by saying when, and then the sort of condition that we want, right? So essentially, again, we're only calling this function when number is greater than or equal to Arabic. So we effectively remove that part. This might not pass, I don't know, let's see. Undefined function tail, okay. So I'm not extracting tail in this one, so we need to grab tail. And this is also complaining because tail is unused, so let me prefix it. And then here we're not using head. What is this complaining about still? Oh, values. All right, so we don't need to like use the values anymore. We only care about the tail. So we can just pattern match on the tail. if we were to grab values out, then that will just be the same exact list that we call or that we pass into this sort of iteration of the function. In this case, we just care about the tail. All right, so recap, we've effectively just went from this, and it's like, all these if else, nested if else, into something more that's like declarative, right? Oops, this is not supposed to be. Here we go. And of course, we can make it cleaner because, as you can see, all these functions are just one line. So we can do that comma colon syntax that we did on line 9. Let's do it here. And also by doing that, you don't need the end because it's just one line. And cool, our test will pass. And if we want to keep continuing this, like I'm not going to do every single number because that's just going to take a long time. Let's do 5. That should still pass. There we go. Oh, I didn't save this test file, whoops. But there we go, 5 tests, 0 failures. And so I guess things to note is that you can pattern match on functions. So as I mentioned before, if we want specific behavior to only happen depending on whatever we pass in, we can just explicitly write that as we did before, where we just do 1, this, right? And since technically 1 can, this is true for 1, right? This is also true for 1 because there's nothing that's checking if whatever number the number is passed in here. We're not doing any checks. So in this case, it's just gonna find the first function match and then call that one. So this is kind of hard to see in this example, but tests are still gonna pass. There we go. All right, that's it for my demo. Oh yeah, so things to note. We can sort of simplify the logic using a guard, as I mentioned. We don't need to write an if statement. We can do this guard, and that sort of eliminates having to write the if statement, right? Because we can just check for that condition sort of within when we define the function here. Pattern matching, you can pattern match explicitly on values that you expect, and you want to do certain behavior this is our base case, so we want this to match when the list is empty. Same with the 1. And then lastly, the piping from earlier. So I'd say those are some of the coolest things about Elixir in my opinion. But I encourage you to, try out Elixir and, have fun with it. It's yeah, especially if you're coming from an OOP background, it might challenge you. It definitely challenged me, but if it doesn't challenge you, then hey, that's good on you, I suppose. All right, so that is it for my demo. The Elixir docs I use all the time. They're actually quite helpful compared to other documentation I've used. The Elixir forum is very active and helpful as well. I ran into a couple of issues and posted a question and got a response within the same day. And there's also this cool documentary that I really like, and it just pretty much shows you what Elixir is and then how other companies use and leverage Elixir to sort of solve their issues and problems that they have. So that is it for my talk.